Sir Ken Robinson said, "Creativity is the process of having an original thought that has value." And through that lens of seeing creativity, we believe that our algebra program is well suited to asking students to think creatively, to approach problems with their own ideas and their own thoughts. And we think that that is extremely important for all of our students in whatever they do for the rest of their lives. The landscape of the workforce that our students are going to enter is going to change drastically from now until that point, 8, 10 years from now, and particularly over the course of their careers. So we want to prepare our students to be able to solve open-ended questions that they've never seen before. So we believe that it's important with algebra to be a very strong curriculum to prepare students for any STEM field, that they have all of the traditional skills necessary to solve the problems for those fields. But we also believe it's an opportunity for every student to develop in her critical, creative thinking, problem-solving skills.
Here is an example of dividing polynomials that we would do in class. It has the basic algorithm and steps, and it shows the students what to do with the remainder at the end of the problem. A challenge homework problem would be something like this, a step above what we had done in class. They would still have to use the algorithm from class, but at the end they'd have to realize that since this is a factor of this polynomial, the remainder should be 0. So if k minus 9 is the remainder, they should understand to make that equal 0 and then solve the problem where k is 9.
The emphasis on problem-solving skills adds a new level of rigor that most middle school students have not experienced. We don't always expect that every student will complete every homework problem. We do expect them to try every homework problem. This is a time for them to practice not only the skills they learned in class, but also the skills of how to approach new problems. By the end of the year, the student should be able to solve problems that we've seen before and also be confident when solving new problems.
You just do factor 63 first. So I did 9 times 7, and then it's 3 and 3. Then you do 7 times 3 times 3. And then this, as Annie was explaining before, like it becomes 1 3. So 3 root 6. That's 6.
All right, good.
Now the beauty of variables is we're doing something with something universal, right? So we can apply a rule to something when we don't even know what the number is, right? So with 196, its square root is exactly 14, and it's just 14, right? But with a y, it could be anything. The y could represent anything, right? But the square root, what do we know about a square root that is sort of restricting?
The SAT is so important because they're not only routine questions, but the SAT has many mathematics questions that require higher level thinking. It's hard to truly prepare for the higher level SAT questions by taking an SAT prep course. Students really need to be able to draw on 3 years of curriculum taught at a high school. Because Georgetown Visitation is a college preparatory school, we want our students to be well prepared for the math SAT. What we've done is categorized sets of SAT questions from SAT prep books according to the chapter in our textbook. This question here is not typical of a math textbook problem. It requires some higher order thinking, but it does use a skill from chapter 5, namely that's factoring out a greatest common factor. So in this problem, the students would have to recognize that x could be factored out of the expression. And then, what is the value of x when a plus b is 12, conveniently, the students would see that a plus b, the quantity, is already in parentheses. When that's equal to 12, then 12x equals 36 and x equals 3.
We also challenge our students to see mathematics in the world around them. One of the ways that we do this is through math consultant letters, where we turn our class into a firm of math consultants. And throughout the year, the students will receive random letters asking the students for their mathematical expertise and help. The students have to read the letter and mine them in situations that they might not have initially expected a mathematical solution, to find a solution, and then to write a response letter to the people who mailed it to them in the first place. So we're asking our students to think hard about how they can apply former skills that they've developed, how to apply them to new situations that might be unexpected, and to articulate their mathematical skills to people outside of the mathematics community.
We like to give the students what we call math editor problems, in which there's an original problem and there's a solution already written out. However, the solution is incorrect, and the students have to figure out what's wrong with it and then make the appropriate correction. This question number 1 is one of the most common mistakes. This is a form that we call the difference of squares, and oftentimes students will factor it like this by simply taking the square root of the first term and the second term, but that's not correct. The student would have to recognize that difference of squares is factored like this: x plus 7, x minus 7. We hope that this emphasizes common mistakes and helps students avoid those by looking at it from a slightly different angle. Instead of simply giving them the problem, x squared minus 49, we also give them the solution, and then they really have to think about it from a different direction.
We also have a group of worksheet types that's called generically tasks that ask students to do all sorts of different things with the ideas. This is one example where students are given half a dozen different equations of lines, and rather than going through the algorithm of simplifying them into y equals mx plus b format, or to solve for the y and x intercepts, the students need to really think about what does it mean to be a point on the line, to find which of those points match the equation of the line. And then after the students do that, they need to move down to the graph of the line, so that the students really think about how does changing a couple subtle things in the equation change the graph of the line rather drastically. This is also extremely important for our students to understand the relationship between equations, points, and graphs, that mathematically these are all together, and that relationship is ultimately going to be very important as they progress forward in their mathematics.
That was good. For the Make a Quiz worksheets, we give the students some problems with 4 blanks, just like a blank multiple choice quiz would be. The students have to come up with not only the correct answer to the question, but also common mistakes that they've seen either themselves or their peers make. We think that the Make a Quiz technique is great because students become very aware of common mistakes.
All the STEM fields require that you solve problems correctly, and they all use algebraic skills to do that. So it's very important that our students are able to solve problems with tremendous accuracy, so that all of the doors are open to them in the STEM fields of science, technology, engineering, and mathematics.